Of the many profound mysteries that have led cosmology into its current and ever-deepening state of crisis, perhaps none are more edifying than the puzzle of the life and death of a star. Standard astronomical theory states that stars form in isolation by gravitational collapse in nebular clouds over eons of time. Stars are powered by nuclear fusion in their cores until they inevitably run out of fuel, leading to gravitational collapse. If sufficiently massive, the imploding layers of the star are thought to, quote, rebound when they hit the core, resulting in an explosion, and the blast wave ejects the star's envelope into interstellar space. Following the Herzbrung Russell diagram, astronomers believe they can assess the age of a star, which is thought to offer a vital clue to the conditions of the universe since the hypothetical Big Bang, roughly 13.7 billion years ago. This reasoning has led to the theoretical creation of a veritable phantasmagoria of Star Trek-like stellar objects, which defy long-held principles in physics and are increasingly repudiated by scientific discovery. In contrast, plasma cosmology and the electric universe have laid the foundations of a new theory of stars, which strips away the weirdness in favor of a plasma physics model, both experimentally verified and increasingly vindicated by science discovery. Today, we'll explore yet another such discovery, which demands a fundamental rethinking of stellar theory. About 700 light-years away, near the center of our galaxy, a so-called dead star has completely upended astronomers' beliefs about the behaviors of a stellar corpse. The star in question is thought to be a, quote, white dwarf, which astronomers believe is the remnant of a low-mass star. And yet astronomers have observed features around the star which have no explanation at all in standard reasoning. The European Southern Observatory's Very Large Telescope has imaged what investigators interpret as a nebulous, quote, shock wave, or bow shock about the star, which they believe is caused by the star's rotation resulting in interactions with surrounding gas. However, the hypothetical conditions required to produce such effects are not present. As described in a press release on the official ESO website, the so-called white dwarf star, quote, has a sun-like companion orbiting it. In such binary systems, the material from the companion star is transferred to the white dwarf, often forming a disk around it. While the disk fuels the dead star, some of the material also gets ejected into space, creating powerful outflows. But the white dwarf shows no signs of a disk, making the origin of the outflow and resulting nebula around the star a mystery. The co-lead author of a new paper in the journal Nature Astronomy says of the discovery, "The surprise that a supposedly quiet, diskless system could drive such a spectacular nebula was one of those rare wow moments. We found something never seen before, and more importantly, entirely unexpected." These thoughts are echoed in a statement by the paper's co-lead author. Our observations reveal a powerful outflow that, according to our current understanding, shouldn't be there. Now I have to remind viewers of one of the favorite truisms of both Wal Thornhill and retired professor Dr. Donald Scott, both of whom agreed that when astronomers encounter intractable mysteries, a favored tactic is to call on mysterious magnetism as a kind of get-out-of-jail-free card. We see this tactic on full display in the following excerpt from the ESO press release. The shape and size of the bow shock imply that the white dwarf has been expelling a powerful outflow for at least 1,000 years. Scientists don't know exactly how a dead star without a disk can power such a long-lasting outflow, but they do have a guess. The white dwarf is known to host a strong magnetic field, which has been confirmed by the MUSE data. This field channels the material stolen from the companion star directly onto the white dwarf, without forming a disk around it. Our finding shows that even without a disk, these systems can drive powerful outflows, revealing a mechanism we do not yet understand. This discovery challenges the standard picture of how matter moves and interacts in these extreme binary systems. The results hint at a hidden energy source, likely the strong magnetic field, but this, quote, mystery engine still needs to be investigated. The data shows that the current magnetic field is only strong enough to power a bow shock lasting for a few hundred years, so it only partly explains what the astronomers are seeing, end quote. Now, firstly, I'd be remiss if I didn't remind viewers that cosmic magnetism is one of the great unresolved astronomical mysteries, for exactly one reason. The electric currents required to induce said magnetism remain verboten in the standard literature. But the problem goes much deeper, including the longest-standing assumptions about the very nature of stars, including how they form and what powers them. In both the electric universe and plasma cosmology, stars form by the electromagnetic Z-pinch effect along plasma filaments in nebular clouds. As we've already discussed ad nauseum, the clearest possible affirmation of this thesis is the constant and near-constant width of star-forming filaments. I continue citing this point for the simplest reason. It has no conceivable gravitational explanation, including explosions and turbulence, since those mechanisms require that we see a degree of radial curvature imposed on the filaments. However, constant width is completely predictable in the electrical model, as demonstrated beautifully in a lightning stroke, and seen visually in the image on your screen of bead lightning. While plasma cosmology still holds to the mainstream view that stars are powered by internal nuclear fusion, in the electric universe, as described by Thornhill and Donald Scott, a star's power source is external electric currents, which link the star to the parent galaxy. It was from this premise that Thornhill and Dr. Scott presented an alternative to the famous Herzbrung Russell diagram. An electric star is in fact analogous to a type of electric light, with stars falling into one of three categories: neon lights, gas discharge lamps, and arc lights. In other words, differences in stellar color and luminosity can only ever be understood as plasma discharge phenomena. I'd like to share with you now the most salient and succinct description possible of these points from our departed friend and mentor, Wal Thornhill. Wal wrote the following words in a 2008 article entitled "Twinkle, Twinkle, Electric Star." Here, Wal explains that in the electric universe, there is no such thing as a white dwarf star. And in fact, as you'll hear in a moment, this latest discovery does count as a significant predictive success for the electrical theory of stars. The main differences between these types of lights, that is, electric stars, are the power density of the discharge and the location in the gas discharge path where most of the light comes from. For example, in a neon tube, the light comes from the extensive plasma column between the electrodes at each end of the tube. In an arc light, the light is concentrated at the electrode. As the power of an arc light is increased, its color changes from yellow-white to blue-white. The sharp discontinuities in the nature of the light from an electric discharge, as it switches from a red glow to a bright arc, explain many of the mysteries of starlight. Astronomers use the Herzbrung Russell diagram to categorize stars. It is a plot of the absolute brightness of stars against their spectral class, or temperature. The data graphed by the Herzbrung Russell diagram are observed quantities, while assumptions drawn about the diagram's meaning are not. Clearly, not being electrical engineers, astronomers have got things precisely backwards. As you increase the current density to an electric arc, the light becomes brighter, hotter, and therefore bluer. In other words, the current density is responsible for both the luminosity, that is, y-axis, and the color temperature, the x-axis, of the HR diagram. That explains the near 45-degree slope of the so-called main sequence stars in the corrected HR diagram. At the lower left hand of the main sequence, we find the red dwarfs, small stars under low electrical stress, in which anode tufting is sparse, and the light from the tufts is emitted at low energies, toward the red end of the spectrum. A good deal of the red light comes from the chromospheric anode glow. As we move diagonally upward and to the right of the HR diagram, the stars become more massive and the current density increases. Anode tufting becomes more intense, and the tufts' mutual repulsion forces the photosphere to grow to accommodate them. At the top right of the main sequence, the light from the tufts is the electric blue of a true arc, and the stars appear as blue giants, intensely hot objects considerably larger than our Sun. These blue giants tend to be concentrated on the central axes of our galaxy's spiral arms, where the galactic currents are strongest. But what about the stragglers, the red giants and the white dwarfs? Here, the natural simplicity of the electric star model shines. Stellar color and luminosity are discontinuous functions for good reason. Plasma discharge phenomena at an anode exhibit sharp discontinuities. Thermonuclear star models projecting theoretical stellar evolution onto the HR diagram require great imagination to explain these discontinuities. Usually it requires that a star explodes, or else the transition of the main sequence is said to be so rapid that we don't see a continuous plot. The terms giant and dwarf, when applied to these stars, are highly misleading since a star's size is a plasma phenomenon too. And the notions that a red giant is an old, dying star and that a white dwarf is a remnant of an exploded star have no validity. Eddington himself expressed his puzzlement about white dwarfs. He called them, quote, strange objects, which persist in showing a type of spectrum entirely out of keeping with their luminosity, may ultimately teach us more than a host which radiates according to rule. End quote. He was right. A white dwarf is a star that is under low electrical stress, so that bright anode tufting is not required. The star appears extremely hot, white, and underluminous because it is equivalent to having the faint white corona discharge of the sun reach down to the star's atmosphere. As usual, a thin plasma sheath will be formed between the plasma of the star and the plasma of space. The electric field across the plasma sheath is capable of accelerating electrons to generate X-rays when they hit atoms in the atmosphere. And the power dissipated is capable of raising the temperature of a thin plasma layer to tens of thousands of degrees. White dwarfs are often found in multiple star systems, which puzzles astronomers because, quote, it is not easy to understand how two stars of the same age could be so different. The answer is simple. The appearance of stars has nothing to do with their age. In multiple star systems, the brightest primary star usurps most of the electrical power, dissipating the energy in optical wavelengths. The white dwarf converts its share of power most efficiently into X-rays. An example is the nearby double star system of Sirius, which is the brightest star in the sky and one of the closest. Sirius also has a partner called Sirius B, a quote white dwarf. To our eyes, it is 10,000 times fainter than the primary star Sirius A. However, when astronomers pointed the Chandra X-ray telescope at Sirius, they got a shock. In the X-ray image, Sirius A is the lesser of the two lights. Sirius B, the white dwarf, is the greater. It is the reverse of what we see with human eyes. End quote. So here, Wall has given us a theoretical foundation to look again at the scientific puzzle we discussed at the beginning. A so-called white dwarf star is surrounded by seemingly inexplicable nebulous material. Inexplicable because, in standard reasoning, it must have been created by a mechanical outflow of material involving a stellar disk. However, as already stated, said disk does not appear to exist. Further, astronomers' ad hoc resort to mysterious magnetism also fails on its premise, leaving astronomers with yet another unresolved puzzle.